Hello, everyone. Thank you for attending today's Hot Water Forum webinar, Codes and Standards Deliver More Savings Than Meets the Eye. We'll be discussing the role of mandatory and involuntary standards in improving energy and water efficiency. My name is Chris Granda. I'm a senior manager at Energy Solutions, and I'm filling in today for my colleague, George Chapman. I'll be your moderator. Before we begin, I have a few housekeeping announcements. Your screen is customizable. Feel free to make the various windows as large or as small as you'd like. You can even minimize them or them to drop to the menu at the bottom of your screen if you want, so that you can make the remaining windows larger. Click through the widgets at the bottom of the screen to make sure you aren't missing any of the available options. The presentations can be downloaded as PDFs from the resource list in the menu. Now, as attendees, you're in listen-only mode, but can submit questions through the Q&A box at any time during the webcast. The presenters will respond to questions and at the end of the three presentations. So we will not take questions during the presentations, but maximize the amount of time at the end to hear all of your questions. The Q&A can be accessed at the menu at the bottom of your screen if you don't already see it there. All presentations will be available within a few days on the Engagement Hub, also for all of the sessions. At the end of the session, we're going to open a chat room in a different platform in Zoom for anyone who wants to continue the conversation regarding the session or to ask more questions from the presenters. And there's going to be a chat room icon in your menu bar with the link. I don't see that right now, but I assume that will be coming up later. So on behalf of ACEEE, we want to get started and thank our sponsors for the event. So let me just introduce you there. Our platinum sponsors are Ream and A.O. Smith, and our silver sponsors are Bradford White, Green Power EMC, NIA, and SoCal Gas. So let's get started with our first speaker, who's Megan Geis. Megan is a policy associate at the Appliance Standards Awareness Project, where she conducts research on water-using appliances and works to advance appliance standards at the state and federal level. She develops informational material and guides advocacy teams that aim to cut wastewater in their regions. Megan joined ASAP in 2019. Prior to starting at ASAP, she worked as a journalist at Ars Technica, where she reported on energy science, grid-scale developments, and commercial innovations in the energy field. Before that, Megan worked as an editor at PC World and as a fact checker for Wired magazine. In grad school, she worked on grant-funded projects to price out energy generation investments and contributed to prize-winning case competition teams. For those of you who are familiar with ASAP, they work in the U.S. on energy and water efficiency standards at both the federal and state levels. And Megan is going to talk with us today about the state-level opportunities. And let me queue up the correct slide here. And is that right, Megan? I think we're ready to go.
There may be a bit of a lag for me here. We're doing 17, push to audience. There we go. Cool. Hi, thanks, Chris. Hi and good morning. Today I'm going to talk to you about appliance efficiency standards and how they can help states meet energy and water efficiency goals. The Appliance Standards Awareness Project has historically focused on energy efficiency, but appliances also use water, and having standards for water efficient products has never been more important. Drought isn't a temporary thing anymore, especially in the West. Drought is becoming an endemic and persistent threat. Even in the wetter Southeast, flash droughts or rapid onset droughts can threaten overtaxed river beds that feed old metropolitan areas. Using less hot water also saves energy and saves money on both energy and water bills. Among the tools that legislators have to respond to these issues are appliance standards. Faucets and shower heads are in the top 5 energy and money-saving products which states can use to set standards. Water efficiency is also less of a partisan issue in many states. And drought has prompted conservative Texas and Georgia to adopt standards in the last decade. What are standards and who sets them? Standards set limits on how much energy or water a product can use. The U.S. federal government sets some standards on products like air conditioners or dishwashers, and no state can set a more aggressive standard than the feds. We say that these appliances are preempted. In some cases, the federal government hasn't weighed in on a product, and then states are free to set their own standards. In other cases, notably for water-using products, the Obama administration explicitly waived federal preemption, meaning that even though there's a federal water-using standard that everyone has to adhere to, states can set their own standards that are more stringent. These state standards prohibit retailers or manufacturers from selling appliances that use excess energy or water within the state. It's important to note that standards are rules, but the federal government also has two voluntary programs, Energy Star and Watersense. These programs define specifications that the products need to meet to get a special label, but the federal government doesn't enforce Energy Star or Watersense at a national level. Let's talk a little bit about the benefits of standards very quickly. National standards have already saved Americans a ton of money. Currently, consumers pocket $500 per year in utility bill savings compared to if no national standards were in place. State standards are saving consumers even more money in their respective states, but that doesn't apply to states where the standards are not enforced. For plumbing products, shower heads, faucets, toilets, and urinals are especially important to ASAP's energy and water efficiency strategy. These products have federal standards that are well behind where technology is today, but they also have waivers on federal preemption, and that allows states to set more ambitious standards. Faucets and shower heads are particularly notable because of their potential for large energy, water, and money savings. There are a few other water products that ASAP tracks that are outside the federal government scope, like spray sprinkler bodies, commercial steam cookers, commercial dishwashers, as an example. Setting standards at a state level for these products can save millions of gallons of water per year, as well as energy from reduced water heating and secondary energy use, that is, pumping and wastewater treatment. Water-using products are good candidates for state standards because they're not preempted federally, as we recently discussed, but also because for each of these items, there is an existing standard or specification, an existing test method tied to that standard or specification. There are cost-effective savings, meaning buying an efficient product is going to benefit the consumer either immediately or in the near future based on energy and water savings. And also, because compliant products are made by a range of manufacturers. So customers aren't forced to buy one brand of toilet, for example, to be compliant. When we say there's an existing specification or standard, that means that programs like Energy Star or Watersense have specifications to define an efficient product from an inefficient product. California's Energy Commission is also very well organized and well funded, so they often define specifications or standards that other states can emulate. Let's take a closer look at the standards in the U.S. for hot water fixtures. The federal standard, the law of the land, states that no kitchen or lavatory faucets can be sold that exceed 2.2 gallons per minute flow rate. That's pretty general, and since faucets are no longer preempted, California has set more stringent standards, requiring a maximum flow of 1.8 gallons per minute for kitchen faucets and 1.2 gallons per minute for bathroom or lavatory faucets. Watersense, the federal government's voluntary specifications program, requires that a lavatory faucet not dispense more than 1.5 gallons of water per minute to earn a Watersense label on the faucet's packaging. So far, 6 states have published faucet standards based either on California Energy Commission standards or on the EPA's Watersense specifications. ASAP estimates that a significant number of kitchen and lavatory faucet models already meet either the California or the Watersense specifications. And this is good news because it means that customers can find an efficient model easily at any store, and retailers generally need less lead-in time before their stock of inefficient fixtures are turned over. Similarly, 6 states have showerhead standards that are more stringent than the federal government's. California, Hawaii, and Washington are aligned with CEC's more stringent standard, and Colorado, New York, and Vermont are aligned with Watersense specifications. The federal standard is 2.5 gallons per minute. So 73% of showerhead models meet Watersense recommended specifications of 2 gallons per minute or less. And of those showerheads that are Watersense certified, the EPA reports that 63% have a maximum flow rate below that at 1.8 gallons per minute or less. Since manufacturers have produced more than 9,000 Watersense labeled showerhead models to date, this suggests that most manufacturers aren't having a tough time meeting or exceeding California's most stringent standard. An important component to these standards are the test procedures that help define an efficient product. In addition to meeting maximum flow rate criteria that I just outlined, test procedures for these specifications also include performance criteria. For example, it's really important that efficient showerheads perform well because, at least in the US, people are sensitive about their showers. And if your spec is voluntary and it's not meeting customer satisfaction, then no one will buy the voluntary efficient showerhead. Or worse, the Watersense label would lose its value as representative of a good product. So for the showerhead specification, under Watersense, the test procedure defines a spray force test where a showerhead is set up to spray on an apparatus that looks like the one depicted here. And if the force spray is equal or greater to the counterweight, it will move a force gauge located at the peak of the apparatus into the positive range. The result is that high-efficiency showerheads are generally quite well-liked in the U.S. This slide shows the top pick from a popular product review website. And among all the showerheads that this reviewer could have chosen, they found the best and most satisfying showerhead was one that beat even California's most stringent 1.8 gallon per minute standard. Now, if you're based in the US and you're interested in passing state standards, let me just do a quick pitch. ASAP publishes a new model bill every fall. Our 2021 model bill will likewise be published soon, and this year it looks to be very similar to our 2020 model bill, which you can find on our website. Although a lot of the standards work we had been doing in states ground to a halt when the COVID-19 crisis hit, there has been a little bit of momentum for 2021. Standards are actually a great policy to pursue amid the crisis because it helps states continue to make progress on their climate goals. But especially for fixtures like faucets, showerheads, and also toilets and urinals, there's no incremental cost for buying an efficient product. So constituents aren't paying extra for this climate-friendly policy. Additionally, efficient fixtures aren't just cost-effective when you buy them at the cash register, they also help families save money on their utility bills. This especially helps low-income families who generally rely on landlords to install fixtures but have no say in what kind of fixtures are installed. If state standards push all landlords to buy efficient fixtures, then families aren't needlessly paying extra on their utility bills. Finally, Bradley Corporation, a large plumbing fixture manufacturer, recently shared results from a 2020 survey showing that 90% of respondents say they are washing their hands more frequently or more thoroughly or longer, and 88% of respondents said that they are extremely or somewhat likely to maintain their increased hand washing regimen once the virus has passed. So adopting faucet standards will help states reduce water waste despite extra hand washing, which nobody wants to discourage. Wash your hands. Our organization can help local advocates in a number of ways, primarily by offering technical assistance and savings analysis, leveraging our contacts at regional organizations, and as well as water and energy advocacy organizations, and by helping advocates connect with implementers in other state governments. As I mentioned, we have a number of advocates in states all over the U.S. who are interested in passing appliance standards in 2021. That said, we're always looking for more advocates of energy efficiency, so please feel free to reach out to me after this presentation at the email address below or in our Zoom call if you're interested in pursuing standards at a state level. Thank you.
All right. Well, thank you. Thank you very much, Megan, and thank you for being very much on time. All right. And remember, again, we'll take questions in the Q&A period at the end. So let's move on to our next speaker, and that will be Matt Malinowski. Matt's a senior manager in policy analysis at CLASS, but he leads their efforts on impacts modeling, and he contributes to program design and implementation, adding a robust technical, analytical, and policy skills to the policy and analysis team. Matt has over a decade of experience in government energy consulting, and he's a recognized technical expert on reducing the energy use of buildings through more efficient electronics products. And he's interfaced between policymakers, businesses, and environmental groups to advance efficiency. Matt has master's and bachelor's degrees in electrical engineering from MIT. And CLASP is an international organization that does a lot of work in developing countries. And Matt will discuss how to tap into water efficiency as a huge global greenhouse gas reduction opportunity. Now, let me just cue up the beginning slide here. All right, hopefully, Matt, are you seeing that your first slide?
I am. Thank you, Chris.
Okay.
Thank you for the introduction. Good afternoon. Good morning, everyone. Again, my name is Matt Malinowski. I'm with CLASP, a nonprofit devoted to accelerating our transition to a more sustainable world. And today I'll be speaking about water efficiency opportunities around the world. So our research into this was inspired by the work of ASAP and others doing a great work in the US. We have a team in Europe which is also working on eco-labeling for faucets and shower heads there. And we wanted to see, could this work be spread more broadly? In the US, ASAP calculated that the CO2 impacts from more efficient faucet and shower head standards would be around 8 megatons in 2030. In Europe, our calculations, also put it in the megaton range. And so we wanted to see, would this scale more broadly? And so we, over the past year, we've been doing an analysis of kind of a broad analysis of countries around the world to see where we could have the most impact, where could we try these kinds of policies. We focused on 3 countries for more in-depth scoping research: India, South Africa, and Brazil, and are now in the process of wrapping that up, developing estimates of CO2 reduction potential. I'll share some of those initial ones with you, and then looking to pursue these kinds of policies. So I'll start with how we prioritized the various countries and how we selected India, Brazil, and South Africa for in-depth scoping. We looked at 2 sets of factors. The first set related to impact, or what is the size of the good? What is the relevance of water efficiency standards in a country? And the second related to policy context. Where can we have success? For countries that scored highly on both those metrics, these are the ones where we're doing more detailed work to really assess the CO2 emissions reduction opportunity, as well as the water savings and other sustainability impacts. Great. And I'm sorry, Chris, you mentioned I was having some audio problems. Do I need to back up or repeat anything?
I don't know whether that was a general problem or just me, but I can see and hear you now. Let's see, I'm not seeing any chat messages from or Q&A from other folks saying that they weren't able to hear you. Oh, let's see here. Nope, I don't. It seems like everybody else was able to hear you.
Okay, perfect, thank you. Great, so continuing with the impact factors. We looked at 3 impact factors. Our primary focus was the energy for water heating. We were primarily focused on CO2 reductions, and so looked at this as a proxy for where could water efficiency standards for faucets and shower heads, 2 fixtures that, at least in the US and Europe, use hot water that needs to be heated, often with fossil fuels. where those standards could have impacts, could reduce CO2 emissions. We also looked at places experiencing water stress, so either long-term water scarcity, where withdrawals exceed the renewal of aquifers, of rivers, as well as short-term water crises, so droughts, what Megan said has driven policy action in Texas and Georgia. And those were both, I think, combined into WRI, World Resources Institute's aqueduct score, which they publish for each country. And lastly, although throughout most of the world, most of the water goes to agriculture, it's really the urban centers that experience water crises most acutely. You may remember the day zero kind of crises in Cape Town, in India, where cities were going to run out of water, and again, that focuses a lot of attention on the problem, as well as could have a large impact, especially when we're talking about water fixtures like faucets and shower heads. So those are the impact factors that kind of quantify the size of the opportunity. The likelihood of the opportunity we try to quantify through these three policy factors. The first was the presence of overarching water-related policies. So does the country have a water agency, a water resources plan, targets for conservation? These kinds of policies, they're not very specific, but they highlight that this is a priority for the government and for the nation, and bolster efforts in this area. Secondly, do they have experience with actual specific water efficiency standards and labeling? Again, in the US, Megan described the framework of voluntary requirements, federal requirements, some experience with state requirements. All of those show that water efficiency is possible, that there is expertise, there are local experts that know about the product, the process, and that manufacturers and civil society are likely engaged and understand the process, the potential benefits of water efficiency standards. We wanted to make sure, though, that those water efficiency standards, we scored the ones that had not been updated recently more highly as kind of a more ripe opportunity. So we wanted that sweet spot where countries had water efficiency standards, but maybe had not updated them in a while. And lastly, we looked at energy efficiency standards and labeling. So this is CLASP's bread and butter. We've been working in energy efficiency for over 20 years. We think that some of these same processes, skills are applicable to water efficiency. So, the data analysis process, the stakeholder engagement process, of course, the stakeholders will be different, the government agencies will be different, but again, it could be an example or an analog of that can be transferred to the water efficiency space. So all of these factors were weighted pretty much equally, and showing them here on this graph are the top 18 or so countries that, in terms of CO2 emissions from the appliance sector, these are some of the countries that CLASP is really focused on. We have the policy prerequisites across the x-axis, the impact factors across the y-axis, and the size of the bubble is that energy for water heating, the metric that was our primary metric. As maybe is not that surprising, the more populous the countries, or in the case of the EU, the whole block of countries, the higher the population, the higher the water use. The countries that you could think of as maybe being a drier, kind of rise to a little bit to the top of the graph. Of these countries, we selected India, South Africa, and Brazil, as I mentioned. These are not the ones with the highest energy for water heating. But if we look at the U.S., again, there are standards efforts already underway. In the EU, CLASP is likewise engaged in the eco-labeling effort for faucets and shower heads. And in China, they're actually a leader on water efficiency labeling as well. So, the next one is India, and then we focused on South Africa and Brazil to get kind of global variety, to see what the situation is like in various countries around the world. So let's look at what those results, some initial results from these three countries are. In India, we have about 44% of households have water delivered in the home. And that's something we'll see throughout, is that, these countries have large populations, but, not everybody has water in the home. That leads to about 110 million shower heads installed by our estimates. And there is a voluntary labeling system. The water efficient products label, you can see here it has 3-star levels. And I've listed the levels both in liters per minute and gallons per minute. And we can see that what we calculated is that replacing all those shower heads, going from the conventional to the 1-star, not a big improvement, but would reduce the CO2 emissions across the country by 11 million tons per year. In South Africa, similarly, less than half of the population have water in the home. Smaller fraction use water heating, mostly electric storage, and that's a big factor there contributing to rolling electricity blackouts, water heating during peak periods. The best opportunity there seems to be adding requirements to the National Building Code. And, the one proposed requirement would be 9 liters per minute, about 2.4 gallons, and that's a 40% improvement over the baseline. And that would reduce emissions by 5 million tons per year. And lastly, in Brazil, that seemed to be kind of the smallest opportunity. We don't think of Brazil as a particularly dry country, but the water is not evenly distributed, and so there is a lot of interest in water conservation. However, most of the houses are cold water only. Water is just heated at the point of use through these electric shower heads that are pictured there. It's an inline water heater combined with a shower head, electric inline water heater. And their flow rates are already pretty low. They're typically, I think, around a gallon, while maintaining a temperature rise of 20 degrees Celsius. Once you increase the flow rate, it drops. I think at what some local commentators think is the typical flow rate, they can only provide 10 degrees Celsius of temperature rise. So it ends up being a pretty small energy and CO2 potential. So that's, again, some initial findings. We'll be we're reviewing these. We'll be publishing those later this summer. But it seems like the best path forward, or the biggest opportunity, is kind of a national effort to bring together diverse stakeholders. There are ministries that have not regulated water efficiency, but there are others that have regulated energy efficiency. There may be opportunities for learning, for doing kind of national policies towards testing, labeling, standards, and compliance. And there's lastly an international effort through the ISO to develop compliance and labeling of levels for water efficient fixtures based on the Australian WELS label. Again, we'll be presenting publishing more later this summer, and happy to take questions after the next presentation. Thank you.
Okay, well, thank you very much, Matt, and thank you also for staying on schedule. And as Matt mentioned, we'll be taking questions at the end, and just submit them into Q&A, and we'll queue them all up for our speakers. So our last speaker this afternoon is going to be Amin Dalaga. He's a senior mechanical engineer at Pacific Gas and Electric Company's Applied Technology Services organization. The Performance Testing and Analysis Group conducts lab research primarily to support the PG&E Codes and Standards program, which I work with. Eamon has been involved in lab and field hot water systems research for 12 years. Today, he'll share some thoughts with us regarding the water heating savings opportunity in California. And here, let me just get you queued up correctly. Is that the correct first slide, Eamon?
Yes, it is. Thank you, Chris.
Great. All right. It's all yours.
Great. Thank you. Hi, everyone. Today, we're going to be looking at how California unlocks the hot water savings through the Codes and Standards program. We're also going to look a little bit into how our company, ATS, Applied Technology Services, really supports the Codes and Standards program through laboratory testing. The work that we're doing currently is in multifamily buildings, and we can get into that at the tail end of the conversation. Moving forward, the Codes and Standards program supports the Energy Commission in their development of building codes and appliance standards. They also really support the advancement of building energy modeling simulation tools. And a lot of this work is accomplished through laboratory testing to collect data, to build these robust models, and to do the analysis to really incorporate them into the software. And a significant portion of the hot water work flows into the Title 24 standards. And, Codes and Standards is involved on a number of levels from the federal, state, and local level. They support building codes and appliance standards. Looking at it from a federal level, they support the model base codes, ASHRAE and IECC codes. They also support the stretch codes. In California, the stretch codes are called the Cal Green codes, or the Cal Green or building standards codes. And throughout at the local level, they also work with local cities to go beyond the state codes to adopt the stretch codes. And so they support going the extra distance. And at most levels, they also do a lot of compliance improvement work as well. Now, switching over to appliance standards, the California Codes and Standards team works on advocacy, really going out to Washington and working with the Department of Energy and the EPA. And they play a huge role, the only state that really goes to on the federal side and really supports the federal program. And on the state side, we do have a Title 20 standards development side, and and that's really the menu of opportunities. Megan spoke regarding residential faucets and shower heads, and the current standards in California are these Tier 2 standards, and they've been really instrumental in really squeezing as much electrical, gas, and water savings as possible. And that's on the appliance side. Moving more on the building side, that's where really there's a lot of potential savings from hot water systems. In fact, the overall work is, I do apologize for my dog is barking in the other room, but the overall Codes and Standards savings is significant, roughly 875 gigawatt hours and 175 megawatt hours. And that includes another 25 million therms of savings annually. And that includes new construction and with alterations. The hot water measures are a smaller section of that currently. We're looking at replacing resistance water heaters with heat pumps. That's about 62 gigawatt hours of savings. Doing work in that multifamily central heat pump water heater program. That's going to save another roughly 1 million therms per year. There's also work being done with improving the efficiency of boilers, another 750,000 therms of savings. And lastly, there's work done on the multifamily domestic hot water side, really the systems saving side, with significant savings there as well. If you'd like more information on all the work being done, the website title24stakeholders.com is a great resource. There's lots of information there, and I definitely encourage you to take a look. So kind of in closing, when we're looking at the codes and standards side, there is, there's been a lot of work done starting in 2004. And really when the Obama administration came in 2010, the work done on the state level in California was also supercharged by the work done on the federal level. And we can see that the combination of the statewide codes and state and federal standards have really supported California significantly. And we're able to meet our demand goals, our electricity and gas savings goals significantly through the combined codes and standards program. Currently, to meet our energy goals in California, we're able to meet over 50% of our portfolio savings while just using roughly 3% of our portfolio budget. So codes and standards are very effective. They're very successful in California. Not to say that the work done with the incentive programs and all the R&D and emerging technology work that's done, that's still really needed and really supports the codes and standards program, because you have to start somewhere. You have to kind of figure out what is effective in the field, where the savings can come from, and then over time, after we get through the incentive programs, they mature to kind of being regulated or becoming a standard. So I wanted to kind of transition from the codes and standards discussion to kind of the work that's being done behind the scenes, in many cases, to support codes and standards. And I work for Applied Technology Services, and our small team, we actually do a lot of lab testing. We also do energy efficiency reviews in industrial facilities. And this is a kind of a picture of some of the different, in the lab, we've been able to test hydraulic circulators, commercial HVAC equipment, commercial dryers. We have tested heat pump water heaters and boilers. And currently we have 6 environmental test chambers and 1 large room where we can do all this testing. So we've been expanding significantly in the last 5 years. And currently the project that I'm involved with that's relating to hot water systems is we're doing work on heat pump system performance testing in multifamily buildings. And it's a really exciting time, and there's lots of work being done in this area. The work that we're doing supports really updating the CBEC compliance software and for multifamily water heating. The work done previously really was focused on gas boilers, and we really didn't have an option for electric heat pump water heaters. And outside of looking at it from the appliance side, we're looking at it on the system side. So there's current holes with the compliance software. We weren't looking at how, when that hot water returns back to the storage tank, and the impact that it has on the efficiency of the system. So we get to go deeper, really look at the entire system. Some of the things that are maybe outside of the scope that we're looking at while we're doing this research includes really gaining some experience with demand controlled circulation. We're also really looking at mixing valves, and namely digital mixing valves, to see how they can work, especially since Legionella has become a growing concern, and it's something that mixing valves will definitely be incorporated, and especially with heat pumps that are able to bring the hot water to a much higher temperature. So, and I just wanted to give you, I'm just going to kind of talk over these slides, and they're just here for additional information if anyone's interested. The current testing that we're doing looks at a variety of heat pumps and storage tanks, run roughly 24 configurations. And we're looking at almost residential size units with like an 80-gallon unit, starting at 1.2 kW of heating capacity, all the way to like an industrial size unit, which is a 60 kW heating capacity unit with 1,200 gallons of storage. And we're looking at 3 different refrigerants. And as mentioned, we're looking at it from a system side. So we're looking at systems with no continuous recirculation, with continuous recirculation, and then with pump controls. And so the type of testing that we're going to be doing is steady state testing. This is really looking at the appliance or the heat pump. And we look at a variety of different conditions in the laboratory. And we're there to really figure out what the COP of these heat pumps are, how much input power they use, and what is their output heating capacity at a variety of different conditions. And the work that we're doing is on these larger units that haven't been previously tested. And, it's going to really add to the software tools coming out. This picture is a little small, but we also do systems testing where we actually, this is a swing tank configuration developed by Ecotope. And we're looking at a primary heat pump in this configuration, heating up the 2 upstream storage tanks. And then we have the downstream storage tank, which is the swing tank, it basically maintains a recirculation loop. And you can either use resistance heating or another heat pump, like a multi-pass heat pump for that application. And so the key pieces is we're really looking at the impact of the whole system. And we're looking at apartment sizes ranging from 4 to 88 units. We're mimicking basically these large apartment buildings in the laboratory. And this is kind of what our laboratory looks like. This is the 4 and 8 unit apartment building that we have built in the lab. And we, as you can see, we have distribution piping. We have the table. Underneath that table is where the draw station is that mimic the apartments. And we're able to run that 24-hour test with different water flow profiles and share those results. And all that information gets incorporated into the modeling tool. And so I'd like to thank you guys all for your attention, and just want to provide this link for additional information on the codes and standards work being done.
Okay, great. Thank you, Amin, and thank you for staying on time. All the presenters did a great job today. Okay, so if you look at the bottom of your screen, there are a number of button options there, including Q&A. And that's where you can submit questions for the presenters. We have a few that have come in already. And I will queue these up, and we'll get going with a bit of a chat for about 15 minutes. And then when we're done here, we can also go to a Zoom chat room, and you'll have the ability to interact directly with the presenters if you would like to do that. Let's see if I can do this correctly, putting this, yes, now, questions, is that gonna work? Did that, okay, no. Oh, well. The chat room information will come up again in just a second. Let's start with one of these questions. I'm going to start with one for Megan. Megan, the question is can you comment on the interaction of water savings and energy savings, and how far upstream should energy consumption from, I assume, from water distribution be counted?
Yeah, thanks. That's a great question. In our savings analysis, we only are counting direct water use, but we know that wastewater treatment, or energy used for wastewater treatment and pumping are significant sources of energy. I saw this question a minute ago, and I pulled up a statistic we have that's roughly 3.5% of current total U.S. annual electricity consumption is used for pumping and treatment and energy embedded in water, and that's a really significant number. It's something I wish that we had more concrete data for. We just know that it exists and it's a large number. So if anybody out there does have, can point me to a great source of information for how much energy can be avoided by using less water in secondary energy use, that would be great to see. But for the moment, we just count water that would not is not otherwise used directly from the faucet or from the shower head.
Okay, thank you for that.
Megan, I can just add in. I think the report that we've seen, I think that was done for the Congress, had maybe 70% of the energy in water in the U.S. is from the heating. The remaining 30 was from pumping and treatment and desalination.
Great, yeah.
Though I imagine that must vary pretty significantly by region, wouldn't it? I know water,
for sure.
The further west you go, the farther water gets pumped generally, I think.
Yeah. Yeah, I think it would also vary based on how the water. I mean, in some communities, water is pumped from a well, right? In other communities, you have like large public utilities that are supplying water. Yeah, it definitely depends regionally.
Okay, great. Let's see. Have a few other questions here for Matt, particularly. Matt, in the sample countries that you looked at, what's the share of solar water heating?
Sure. The share was quite low in Brazil and South Africa. I think it was around just 0.5% of. And I'm having trouble right now remembering whether it was all households or just the households with water heating that had solar. I'll dig it up and try to clarify in a minute, or maybe in the Zoom chat. In India, it was higher. It seemed like India was definitely a leader in solar water heating of the three countries we looked at.
Chris, if you're speaking, I don't think we can hear you.
I'm sorry. I committed the cardinal sin of not paying attention to my own mute button. All right, I'll try that again. Another question for you, Matt, was after those countries that you queued up for us and discussed, what would the next ones be on your list? And what about Mexico particularly? A questioner asked about Mexico's particularly hot, dry, and populous country.
Sure. Yes. Thank you. I think Mexico was definitely going to be our first choice in the Americas. Unfortunately, the government there seems to be opposed to regulations from kind of the initial scoping that we had done in early 2019, and so it did not seem like a ripe opportunity politically. As far as other countries, it definitely there is a balance between countries where there are large populations in the developing world, which are typically a good good target for efficiency standards. A lot of those countries tend to be warmer. There isn't a lot of water heating. So I think maybe, looking at a little colder countries, I mean, from our graphic, you could see maybe, I'm not sure what the situation is in Korea. I'll just share that slide again, if that's okay, Chris. And
sure.
Yeah, perhaps Turkey. Unsure. Definitely Pakistan. I think after India, I think the next choice would be probably Pakistan, where we're already engaged with policymakers there.
Great, thanks, Matt. Okay, great. We've got some more questions coming in here now from folks. Let's see. One question, and this is, I think good for Amin, but for others as well. How do you see utilities collaborating with other agencies to add water conservation goals? The questioner works in the Northwest, where there are more than 130 energy utilities, and collaboration occurs for energy conservation efforts, but it's certainly a complex process. I mean, I imagine you have some perspective on that because it's complex in California as well.
Yeah, let me better understand the question. Chris, was that the water utilities working with the energy utilities, or was that other entities working?
Well, it said utilities in general, but I think it was specifically relating to energy utilities, because I get probably because energy utilities are more likely to already have customer energy efficiency programs in place, and maybe there's ways to collaborate with them on adding water efficiency measures to those existing programs.
Okay, great. Yeah. So, I mean, there's through these different stakeholder groups, currently there are significant work. The utilities are collaborating through like a heat pump group where they're sharing research, sharing what's going on, really trying to make sure their programs are all kind of aligned and working towards mutual goals. We're trying to make sure that we're not repeating the efforts, but really funding the efforts in a way that we can get the maximum out of it. And if we're all working together on significant portions of the work that needs to be done, therefore collectively we'll get a lot more out of it. So there is work being done, definitely kind of in our focus more on the west coast, I would say. But we would be open to work with any energy utilities out there or other programs to make sure we're working together and moving forward. So I hope that answers the question.
Yes, thank you. And if there's more follow-up on that, just ask folks to join the Zoom chat room afterwards. We have time for a few more questions here. Matt, there's one from a attendee who's at the University of Watersense in South Africa. And the question is, do you find that government organizations and other stakeholders are receptive to your suggested interventions?
Yes, we've had, again, kind of a real enthusiasm in Brazil. In South Africa, it definitely seems like there are some agencies that are already tasked with developing a water efficiency label. I think that was the Department of Water and Sanitation and SABS, the South African Bureau of Standards. So I think there are already efforts, and we're going to try to engage and support those efforts.
Great, thanks. And then there's a question that's come up that I'm going to open this to everyone, because I think everyone may have their own ideas. Is where can people find the most comprehensive lists of the most efficient water using appliances? And I think that you can ask that question on the U.S. basis and on a global basis. And I've got some ideas, but let's hear from the presenters first about where they go to find what's the latest and greatest. Maybe Megan, you want to take the first run at that?
Sure. Yeah. I mean, so as far as appliances themselves, I guess I took this question to mean like, which appliances save the most energy and water? For that, I suppose I go to Appliance Standards Awareness Project put a report out in 2017 called States Go First. And if you go down through the pages, and I'm looking at it right now, I'm not sure I can share my screen here, but page 26 at the bottom, there's a nice little graph that shows faucets save the most, lawn spray sprinklers, shower heads, toilets, and then urinals. For individual products, I'm not sure how I could find the like a ranking of which ones are the best within like a classification like shower heads. Besides looking for like a Watersense labeled product if I'm in a state without standards. Did I answer that correct? Anybody else want to jump in with a better answer?
Yeah, I can. I agree that the Watersense or the Energy Star label is a great place to go if you're looking for specific products. Anything from dishwashers, which is an appliance, to faucets or shower heads. And they also offer a lot of specific information on products outside of single family applications. So I come from the hot water or the restaurants and food service side. And so there's a significant amount of information like pre-rinse spray nozzles or commercial dishwashers. There's a lot of different types of appliances that you can find specific model energy and water specifications for ratings. So, yep.
Matt, do you have anything to add to that?
No, nothing to add.
Yeah, I'm not sure. I think that's a pretty good coverage as well. I'm trying to think on the international front for some kind, not for water only appliances like faucets and shower heads, but for things like laundry appliances. I believe Top 10, which is a website and service that's run from Switzerland, can tell you the most efficient some water using appliances that are available on the European market. And I can't think of any other ones for the US.
One extra that I could add. Sorry, go ahead.
Yeah, I was going to say that's one of the challenges we've been finding internationally is there is very little testing, no databases. There's just a gap of this. A lot of the test methods are still focused on maximum flow. They don't test. I'm sorry, testing for minimal flow rate. They don't test the maximum flow rate. So the data is just not there. Okay,
and one of the attendees has commented that there are databases on the EPA website of qualified products for both Energy Star and Watersense. Yep. Just mentioning that again. I have a question. I guess it's primarily for Amin, but I'd like anybody to take a whack at it, and then I think we're about done here today. Is what do we know about changes in consumer or in user behavior with more efficient products? One of the things that you hear from manufacturers sometimes is that, if you have a faucet a lower flow faucet, people will just run it longer. Is there much in the way of empirical data that really observes how how water use changes when more efficient water using products are put into the field?
Yeah, that's a great question, Chris. I'm not aware of any reports specifically that really look at single-family homes or just the residential side on how a more efficient shower head or a faucet really impacts the user, and if it changes the user's time frame that they're, say, in a shower or or washing their hands in a faucet. It all depends on the performance, and that's where having a performance rating on the piece of unit, it could be, on the cold water side, it could be the toilet. There's MAP testing that tests the performance of toilets and flushing, and therefore we are not in a situation where folks are putting in, toilets that are efficient, but then they're flushing twice. So that listing really allows the consumer to see, does this toilet work really well? I don't believe that that's really been established with, say, faucet aerators or with, shower heads. But the federal guidelines, they do have a force test. They do have other ways of really looking at the performance. But how does that translate to the user? I don't believe that those studies have been done. So, a great question.
All right. Well, we're about at time today. Thank you very much to Megan, Amin, and Matt for giving great presentations today, and thank you to all of our attendees for your attention and your excellent questions. Again, if you'd like to continue exploring these topics, please follow us to the Zoom chat room. I just posted that to the chat, but I don't know if that went generally to everyone. Well, here, I'm gonna, I don't know how to put it up on the screen, unfortunately. Maxine, I don't know if that's something that you're able to do, but I'll read it out to you. It's https://zoom.us/j/93605778018. And thank you again for joining us today.
Thank you.
Thank you for moderating, Chris. That's great.